Tonight, let's drift into the quiet places where science becomes a lullaby. Imagine a window slightly open to the night, moonlight on the floor, a hush in the trees, your breath moving like a soft tide. Out there, the universe is unhurried. Stars hum in ancient chords, galaxies turn with patient grace, and time itself walks barefoot. We're going to stroll through the most relaxing facts of the cosmos, not to study or solve, but to feel how wonder can loosen the day from your shoulders. I'll be right beside you, like a gentle friend in the dark, telling small, tender truths about space and light, gravity and chance, until the mind grows drowsy and the body remembers how to rest. If this quiet company brings you ease, you can softly tap like and subscribe. No rush, no pressure, just a bookmark for future nights. For now, let your thoughts float like lanterns on a slow river. We'll listen to the universe breathe and let its calmness become your own. They say the universe is about 13.8 billion years old. That number has been whispered through telescopes and equations, printed in textbooks, and spoken by countless scientists staring into the dark. It's a number carved from light itself, drawn from the faint glow that still lingers from the universe's earliest dawn, what we call the cosmic microwave background. From that glow, and from how quickly galaxies drift apart, we've built our cosmic clock. But even clocks can stutter. Some stars seem older than they should be, their light carrying secrets that don't quite fit. A few ancient galaxies appear too mature for their place in the timeline. Some physicists wonder if the universe has been expanding at a changing pace, if what we call dark energy has shifted its rhythm over time. Others quietly ask, could we have misunderstood the music altogether? What if the universe is older than we thought? What if 13.8 billion years is only one verse in a longer, stranger song, one that began long before the first light ever broke free? Out there, scattered through the galactic dark, drift worlds without suns. They are called rogue planets, and they travel alone, unanchored, unseen. No sunrise ever touches their horizons. No warmth spills across their skies. Some were born near stars, only to be cast away by the chaos of gravity flung out like forgotten stones. Others may have formed in solitude, heavy with gas and silence, never bound to any light at all. They wander endlessly through the black, guided only by inertia. If they pass in front of distant stars, we catch a glimpse, a shadow, a flicker, a passing thought in the mind of the cosmos. Astronomers think there may be billions of these lonely worlds in the Milky Way, perhaps more than the number of stars themselves. Each one a silent traveler, frozen in time, carrying the memory of warmth it never knew. And maybe the universe itself drifts in a similar way through cycles of creation and return. The standard model of cosmology tells us that everything began with the Big Bang and will continue to expand, maybe forever. But other visions exist quieter, more mysterious ones. Some physicists imagine a cyclic universe where expansion isn't the end, but the breath between collapses. In these models, the cosmos grows until it cannot stretch further, then folds inward upon itself, compressing everything into a single, luminous seed, and from that seed, another universe is born. Each cycle wipes away the old, yet leaves subtle fingerprints of what came before, tiny irregularities, echoes of ancient universes that once bloomed and faded. It's a comforting thought, in a way that the universe might not vanish into cold oblivion, but instead renew itself in infinite rhythm, no beginning, no end, just the eternal rise and fall of cosmic tides. The oldest light we can still see dates back 13.8 billion years to a time before stars, before galaxies, before space grew transparent. In those early moments, the universe was a dense fog of glowing particles. Light couldn't travel far without being scattered, but as space expanded and cooled, something changed. Atoms began to form, the fog lifted, and suddenly, light was free to move. That light still surrounds us today. It's the cosmic microwave background, a soft, invisible glow that fills every corner of existence. The photons we detect now have been traveling for over 13 billion years, their wavelengths stretched by the expansion of space into cool, gentle microwaves. They are the universe's oldest memory, a faint whisper from when everything first began to see itself clearly. Even now, that ancient light touches you. Every second, countless of those photons pass through your body, gentle messengers from a time when the cosmos was young and bright and full of promise. You are wrapped in their glow, even as you sleep. And out there, far from our sun, other wonders shimmer. In some distant systems, where carbon outweighs oxygen and pressure builds like the weight of a dream, something astonishing can happen. A planet can crystallize into diamond. Astronomers have found one such world, dense, heavy, orbiting the remains of a dead star called a pulsar. It may be a solid sphere of carbon, compressed so tightly that its surface gleams with invisible fire. Not the delicate sparkle of jewelry, but the deep inner brilliance of pure structure, a world sculpted by physics into an endless gem. Deep beneath its surface, lattices of diamond could stretch for thousands of miles, silent and unbroken. No oceans, no clouds, just a planet of eternal pressure and perfect symmetry. It's almost poetic, the ashes of a dead star reborn as a crystal heart, a planet of rock, a planet of gas, a planet of diamond. The universe writes its stories in every possible form. And maybe it has no edges to those stories, only curves that fold back upon themselves. It's tempting to imagine that space has a border, a final horizon we could reach if we traveled far enough. But space doesn't work that way. According to general relativity, the shape of the universe depends on its contents, on matter, energy, and gravity woven together in a cosmic fabric. Most evidence suggests that space is either infinite or so vast and curved that it loops around itself. If that's true, you could set off in one direction, travel forever, and eventually return to where you began, not by striking an edge, but by completing a circle too immense to perceive. It's like walking around a globe, except the globe is made of space-time itself. So the universe may not be infinite in space, but infinite in journey, a boundless path where beginnings and endings blur together, where even in darkness, everything continues to move, to change, to breathe. And maybe that's the most relaxing truth of all. The universe isn't rushing anywhere. It's simply unfolding slowly, endlessly, like a lullaby written in light. They say our sun was never meant to be alone. Long before Earth had oceans or sky, before the moon was even dust, the sun may have shared its cradle with a twin, another newborn star swirling in the same soft cloud of gas and light. Many stars are born in pairs. The cosmos seems to favor companionship, and there's no reason to think ours was an exception. If that lost sibling existed, it drifted away billions of years ago, pulled apart by the slow tidal heartbeat of the Milky Way. Somewhere, far beyond the map of our sight. It may still circle the galaxy on its own silent path, invisible, nameless, yet forever linked to us by origin. Astronomers once nicknamed it Nemesis, wondering if its distant passage could have brushed comets toward Earth and stirred ancient extinctions. There's no proof, only possibility, and that, sometimes, is enough to let the mind wander. So tonight, as you gaze up and see the sun's faint reflection in the moon, remember, it might once have shone beside a companion that vanished into the stars. The warmth on your skin could be half of a duet that time forgot. Far stranger things exist. Imagine a single raindrop small enough to rest on your fingertip, yet heavier than Mount Everest. That's what a droplet of a neutron star would be. These objects are the final hearts of massive suns, collapsed under their own gravity after a supernova's final breath. A neutron star is barely 20 kilometers wide, yet it holds more mass than our entire Sunday. Inside, matter is crushed so tightly that the boundaries between atoms dissolve. Electrons and protons fuse into neutrons, forming a smooth, shimmering ocean of superfluid density. A teaspoon of this material would weigh billions of tons more than every mountain chain on Earth combined. They spin rapidly, some hundreds of times each second, sweeping beams of radiation across space like cosmic lighthouses. In their stillness and their speed, they carry the memory of stellar death, gravity condensed into a heartbeat. They are small, dark, heavy, and astonishingly calm. Even light itself bends in such gravity. Across the universe, light rarely travels in straight lines. When it passes near massive clusters of galaxies, space-time curves under the weight, bending the path of every photon. Astronomers call this gravitational lensing. It's like watching the sky through glass that's slightly melted. The image of a single distant galaxy can appear several times, from several directions, as light takes different routes around the same invisible curve. Sometimes it stretches into arcs, sometimes it forms delicate rings, echoes of one object seen through warped space-time. In rare cases, even the same supernova has been seen exploding twice, one image arriving before the other because its light traveled the longer road. The universe, it seems, knows how to delay its own memories. Light can wander, get lost, take the scenic path, and still find its way home. Now drift back in time to when stars first began. The earliest stars, the population 3 giants, were nothing like those we see today. Born from the pure hydrogen and helium of the Big Bang, they held no metals, no dust, no trace of older worlds. Without those elements to cool them, they grew enormous and fierce, hundreds of times the mass of the Sunday. They burned white-hot and short-lived, shining 1,000,000 times brighter than anything in our sky. In just a few million years, they spent their lives completely, collapsing in spectacular deaths that scattered the first heavy elements into space. From their brief fury came everything solid: carbon for our bodies, oxygen for our breath, iron for the blood in our veins. None of those first stars survive now, but their fingerprints linger in the oldest clouds of gas, in the bones of galaxies, in the quiet chemistry of existence. Their light is gone, yet their work continues in us. You are, quite literally, the residue of their radiance. And while you rest, something else moves through you, unseen, untouchable. Dark matter. It isn't mist or shadow. It's a kind of matter that ignores light completely. It doesn't shine, reflect, or absorb. Yet it has weight. It shapes galaxies. It binds the cosmos together like an invisible web. Around our Milky Way, lies a vast halo of this substance, extending far beyond the stars we can see. As Earth sails through that halo, trillions of dark matter particles pass through every square centimeter of your body each second. They don't collide, they don't linger, they simply flow ghost-like, constant, indifferent. You're immersed in them even now, as you breathe slowly, as your heartbeat hums. Without dark matter, galaxies would fly apart, structures would crumble, and gravity would lose its hold. We don't yet know what it's made of, only that it's here, silent and essential. The universe embraces you with things you cannot see. Not everything that glows is full of stars. In the distant quiet, astronomers have found ghost galaxies, immense systems of gas and dark matter that shine dimly yet contain almost no stars at all. Some were stripped bare by violent encounters. Others never ignited properly to begin with. They drift at the edge of detection, pale smudges on deep sky surveys, like the after-images of vanished constellations. These faint shapes challenge our understanding. If they are rich in dark matter, why did their stars fail to form? If they once held suns, where did they go? Each is a fossil of cosmic evolution, a reminder that not every corner of space burns brightly. Some simply fade into transparency, content to exist without witness. And somewhere, hidden in the background light of the universe, lies a mystery colder than the rest. When astronomers mapped the cosmic microwave background, the oldest glow of all, they found a patch of sky unexpectedly cool. A wide, round region, hundreds of millions of light years across, slightly dimmer and colder than its surroundings. It shouldn't be there. The early universe was supposed to be nearly uniform, its tiny fluctuations spread evenly, like ripples on a pond. Yet this cold spot stands out, not as a scream, but as a whisper. Some think it marks a vast void, an empty region where fewer galaxies formed. Others wonder if it might be evidence of something stranger. Perhaps, long ago, our universe brushed against another. Whatever the cause, the cold spot sits quietly among the stars, a soft bruise in the cosmic light, hinting that reality might be deeper, broader, or more layered than we can yet imagine. And as all of this unfolds, something familiar keeps changing right above us. The moon, constant companion of tides and dreams, is slowly drifting away. Each year, it moves about 3.5 centimeters farther from Earth, the width of a fingernail. The retreat began when the moon first formed, more than 4.5 billion years ago, from debris left after a colossal impact. Back then it hung close, and Earth's days were only a few hours long. The cause is subtle, tidal friction. As our oceans rise and fall under the moon's pull, Earth's rotation tugs slightly ahead of the tide, transferring energy that pushes the moon outward. The change is invisible in a lifetime, but over eons, it rewrites the rhythm of the sky. One day, far in the future, Earth and Moon will face each other permanently locked in mutual gaze, turning together through endless night. For now, the moon just slips away, centimeter by centimeter, leaving us a little lonelier beneath its silver light. Yet even loneliness has beauty in space. Some stars, rather than drifting apart, move closer, close enough to touch. In certain binary systems, two suns orbit so tightly that their outer layers brush together, exchanging matter in slow, spiraling grace. One swells, the other feeds. Streams of glowing gas flow between them like ribbons of light. Sometimes this transfer is calm and balanced. Sometimes it erupts in flares, spinning storms, or a sudden merging into one brilliant body. These encounters are complex, yet the image they leave is tender. two stars bound in dance, reshaping each other with every turn. From such unions are born the universe's most dramatic wonders: exotic supernovae, neutron star pairs, and bursts of energy that ripple through space-time itself. Even among the stars, connection endures. They share, they change, they embrace. And as you lie here, eyes closed, breath slow, you are part of that same cosmic rhythm: separations and returns, gravity and release. The sun's lost twin, the drifting moon, the silent galaxies, the unseen matter, all of it woven into one vast, breathing pattern. The universe is not still. It moves in endless whispers, expanding, folding, glowing, cooling, a dream too large for one night, yet gentle enough to carry you into sleep. So let it. Let the dark widen around you. Let every star, every unseen particle, every quiet orbit remind you. You are inside the story the cosmos keeps telling softly, patiently, forever. The vacuum of space is not truly empty. Even in the deepest, darkest reaches between galaxies, where no starlight glows and no dust drifts, the universe is never completely still. According to quantum physics, what we call a vacuum is a restless sea. Tiny pairs of particles and antiparticles flicker into existence, live for a breath of time, and then vanish again. They appear and disappear endlessly, a quiet shimmer beneath everything we think of as nothing. These fluctuations are so brief and so small that we can't see them, yet they fill all of space with a subtle energy, a low, persistent hum of creation and disappearance happening everywhere, all at once. This invisible activity influences the way real particles move, the way fields behave, even the way gravity pulls. It adds to the energy of space itself, and many physicists believe this hidden energy may be connected to the mysterious dark energy that drives the expansion of the universe ever faster. So when you imagine deep space as silent and still, that picture is only half true. Beneath the calm lies a constant dance, a pulse of possibility, like ripples forming and fading on an ocean too vast to see. Nothingness, it turns out, is never truly nothing. And time, our most familiar companion, behaves just as strangely. We often think of it as steady, flowing the same for everyone, everywhere, like water through a single channel. But the universe doesn't keep such uniform rhythm. Time stretches and bends depending on where you are and how you move. It is woven into space itself, part of the same flexible fabric that gravity distorts. Near massive objects, such as black holes or dense clusters of galaxies, gravity warps space-time so strongly that clocks tick more slowly. A second close to a black hole might last far longer than a second here on Earth. Far from such gravity, time runs a little faster. This isn't speculation. It has been measured. Astronauts in orbit, satellites circling the planet, even atomic clocks on mountaintops experience time differently. The effect is tiny, but real, confirmed again and again. Yet, cosmologists wonder if this difference might also exist on grander scales, whether the expansion of the universe itself could cause time to flow at slightly different rates in different regions. Perhaps in one corner of the cosmos, the stars are aging just a little faster, while in another, the clock of creation lags a fraction behind. If so, time is not a single stream, but a wide river with many currents, flowing at uneven speeds through the landscape of space. The thought is both unsettling and soothing. It means that even the most universal rhythm, the heartbeat of seconds, has texture and motion, In the presence of gravity or speed, time can dilate, slow, or stretch thin, like taffy pulled across the night. Maybe that's why, in a universe governed by relativity, nothing is truly absolute. Even time itself is a traveler, shaped by the places it moves through. It bends quietly around stars, slides gently through expanding space, and folds across gravity's deep wells. If you could drift far enough and long enough, you might feel its pace change beneath you, as if the cosmos were breathing in time's own language, sometimes long and slow, sometimes quick and light. So when you close your eyes and imagine the darkness between worlds, know that beneath that silence is motion, the whisper of particles appearing and fading, the slow flecks of time stretching and compressing, the soft vibration of existence itself. The vacuum isn't empty. The hours aren't even. Reality, at its core, is never still. Everything you see and everything you are rests upon this quiet, trembling foundation. The universe dreaming of itself in endless motion, forever balancing between what is and what could be. The Milky Way you picture, a graceful spiral of stars and dust, is only the bright face of something much larger. Wrapped around that shining disk is a vast, mostly invisible halo, a spherical hush of diffuse gas, ancient star clusters, stray stars, and a great reservoir of dark matter that extends far beyond the visible edge. We don't see it the way we see constellations. We feel it in the motions of stars that move too fast to be bound by the light alone, and in the subtle bending of distant light as it threads through our galaxy's unseen mass. This halo is a record of long-ago encounters, collisions and mergers that stirred the Milky Way into the shape it carries now, leaving behind quiet streams of stars and globular clusters that orbit on elongated paths. It holds our galaxy together with a gentle grip, a soft, pervasive gravity that doesn't shine but steadies everything that does. Think of the bright spiral as a glowing heart and the halo as its transparent body, vast, protective, and old, cradling the starlit disk in invisible arms that reach far into the dark. And farther still, beyond that halo and the halos of countless other galaxies, we are beginning to glimpse the universe as it was when the first lights were only starting to pierce the night. Because light takes time to travel, the deepest images are also the oldest memories, and the James Webb Space Telescope has turned those memories into sight. Astronomers have traced a faint signal from a tiny, primitive galaxy that shone just 200 million years after the Big Bang, a blink against the universe's age, and yet long enough for gravity to assemble a small island of stars out of the cooling darkness. That light began its journey when the cosmos was raw and simple, then crossed a sea of expanding space for more than 13.5 billion years. Its color stretched to red and then to infrared, softened by the breath of the universe itself. What Webb sees is not a grand spiral or a glittering city of suns, but a delicate smear of brightness, small, tentative, and astonishing, holding clues to how the first structures formed when the fog of early matter began to settle. Observing it feels like peering through a narrow keyhole into an era we were never meant to witness. The universe, in its earliest chapters, when chemistry was young, when starlight was new, when darkness had just begun to lose its hold. When astronomers mapped the positions of galaxies across the deepest reaches of space, a pattern slowly emerges from the darkness. Not random at all, but woven billions of light-years of filaments, where matter has gathered into luminous threads, with wide, quiet hollows between them, called cosmic voids. This is the cosmic web, an immense lacework spun by gravity over eons, where galaxies cluster at the crossings like lanterns at intersections, and empty regions open like lakes of night. If you step back far enough in your mind, the resemblance is uncanny. Dense nodes linked by slender bridges, a network that looks, in structure alone, a little like the web of neurons inside a human brain. The likeness doesn't mean the universe is thinking. It simply means that when matter follows simple rules over vast time, it can grow into shapes that repeat in very different places. Still, it's quietly comforting to imagine that the largest thing we know, and the organ that lets us know it, can mirror each other in outline, the cosmos branching into clusters as the mind branches into thoughts, two very different systems, drawn by separate laws, arriving at a similar kind of map. And the roads of that map are not made of stone, but of gravity and dark matter and time, guiding galaxies to gather and drift, to merge and pass, to sculpt the grand tapestry we see when we look as far as light will let us. Amid these immense structures, the stars themselves keep time in a language we cannot hear. Space has no air, no wind to carry sound, but inside a star, pressure waves thrum and roll, rising and sinking like tides within a bright sea. The surface quivers by the smallest amounts, the light trembles not in color but in rhythm, and from those tiny pulses, astronomers can listen with their instruments to a music spread across light years. This listening has a name, asteroseismology, and it turns a star into its own echo chamber, a resonant body whose notes reveal its hidden shape. Each star plays a signature chord, set by its size, its age, and the layers within. Hot zones and cooler shells, currents that move heat outward, cores where fusion beats like a steady drum. By tracing the frequencies of these vibrations, we can read the unseen interior, how fast it spins, how dense it is at different depths, how the flows of plasma twist and settle. It's a kind of cosmic ultrasound, a gentle sounding of light that lets us peer beneath a surface no probe can touch. The sun rings too, softly and always, a vast bell of plasma whose waves glide through its body and return with news from below. Other stars ring higher or lower, quicker or slower, some with a stately pulse like a dozing heartbeat, others with a light flicker, all of them keeping celestial time. And although our ears will never catch those tones, the patterns their light carries are enough. With patience, the silence yields its structure, and a star's quiet music becomes a map. So the universe, on scales both grand and intimate, writes itself in patterns, neuronal in appearance, but cosmic in size, musical in behavior, but made of fire. Filaments stitch galaxies into a web that spans creation. Pressure waves turn stars into instruments that reveal their own design. And you, lying beneath this sky, are tuned to both stories at once. The wide geometry that holds the galaxies in place, and the small, precise rhythms that let us hear into a single sun. The mind recognizes the shapes, the heart recognizes the song. Between them, the night becomes readable, and the dark grows gentle. Galaxies are not born all at once. They grow slowly, patiently, gathering matter and light the way trees gather rings of age. Smaller galaxies collide and merge. Clouds of gas fall inward. Stars are drawn in from other regions. And over billions of years, something new takes shape. That means not every star inside a galaxy belongs entirely to its present form. Some are far older, quiet survivors from before the galaxy itself existed. These ancient stars linger in the outskirts or cluster together in tight, glowing spheres called globular clusters, orbiting far beyond the galactic heart. They carry the signatures of a younger universe, low in heavy elements, high in the simplicity of hydrogen and helium. Many of them were born more than 13 billion years ago, when the cosmos itself was barely out of infancy. Their light still reaches us, pale and steady, a kind of fossilized time. Each one is a whisper from a world that existed before ours, a piece of an earlier arrangement, later woven into the Milky Way's fabric. When you look at the night sky, you're not just seeing stars of one age, but a layered history, some shining with the energy of youth, others burning on borrowed time from an era when the universe was new. And as we study the heavens, we find not only the familiar, but the defiant galaxies that seem to break the very rules we thought were universal. For decades, dark matter has been our quiet explanation for cosmic balance. It is the invisible glue that holds galaxies together, the unseen mass that prevents their outer stars from flying away into the dark. Without it, the galaxies we observe should fall apart, their rotation too fast to be sustained by visible matter alone. Yet, in recent years, astronomers have discovered galaxies that appear to lack dark matter entirely. Their stars orbit in ways that suggest only the matter we can see is present. No hidden halo, no invisible hand. For a long time, this idea seemed impossible, and even now, it remains a mystery. Some scientists think these galaxies were stripped bare during past encounters, losing their dark matter to stronger neighbors. Others wonder if our models of gravity are incomplete, or if dark matter itself behaves in ways we don't yet understand. Whatever the cause, these odd galaxies float through the universe like unanswered questions, reminders that our grasp of the cosmos is still tentative. For every pattern we uncover, there are exceptions. For every truth we settle on, there are quiet rebels drifting at the edge of understanding. Perhaps that's the beauty of it, a universe vast enough to contain both order and anomaly, both the rhythm we can measure and the mystery that keeps us looking upward. In the silence between stars, even contradiction can feel like harmony. Deep beneath the surface of the sun, sound waves roll and echo like the breath of a sleeping giant. The sun rings not with the quick tones our ears could ever hear, but with slow, powerful vibrations that ripple through its layers of plasma. These waves bounce from one side of the star to the other, compressing and expanding its gases in vast, looping cycles. Scientists call this helioseismology, the study of the sun's internal sound. By tracing how these vibrations move, they can map its hidden depths, the swirling convection zones, the dense, rotating core, the shifting rivers of heat and magnetic fields that weave beneath its surface. Each oscillation is a clue, a tone in a melody that never stops. The sun is a bell that never goes silent, its waves too deep for ears, but perfect for instruments tuned to light. Every star carries a similar rhythm, each one sings in its own frequency, the music of structure made audible through patience and mathematics. It's strange to think that our nearest star hums like an enormous instrument, a sphere of fire playing the long, slow song of fusion. Beyond the sun, the same quiet harmony extends across galaxies. When astronomers trace the way stars move through space, they find that galaxies don't drift at random. They travel along invisible filaments, threads of dark matter that stretch between clusters, forming a kind of cosmic architecture. These filaments are the scaffolding of the universe, immense bridges of gravity that shape how galaxies grow and where they gather. We can't see them directly, but we can infer their presence through light itself. Galaxies follow these paths like beads on an invisible string, moving slowly along lines of unseen tension. Between the filaments lie the great voids, vast, quiet expanses nearly empty of matter, so still that even gravity feels thin. This hidden structure is what holds the universe together. Dark matter doesn't shine or glow, but it sculpts the cosmos. It draws galaxies into clusters, defines the contours of the cosmic web, and maintains the balance that allows light to form patterns we can recognize. It's a presence made of absence, a kind of gravitational whisper guiding everything without revealing itself. If we could somehow see the universe in its entirety, not just the galaxies, but the framework beneath, we would witness a vast lace of darkness, intricate and patient, connecting all things. The Milky Way, the Andromeda Galaxy, distant clusters millions of light years away, all parts of one enormous organism of gravity and light. We still don't know what dark matter truly is, and maybe that unknowing is its own kind of beauty. Its touch is everywhere, but its face is hidden. Like breath in winter air, we only see what it moves. Yet its pattern persists, shaping the same paths the stars will follow long after we're gone. The universe is filled with this invisible geometry, an unbroken continuity between what glows and what does not. Even the emptiness between galaxies hums with quiet structure. What seems like nothing at all is, in truth, the delicate architecture of everything that exists immense, unseen, and softly alive. In the early moments after the Big Bang, the universe expanded with a speed that defied intuition. Space itself stretched so quickly that distant regions were pulled apart faster than light could ever travel between them. Nothing in the universe can move through space faster than light, but space itself is under no such rule. It can swell and widen freely, carrying everything along for the ride. That rapid blooming is what allowed the universe to cool, to form structure, and to become the vast sky we see today. Even now, the same quiet expansion continues. Distant galaxies are not racing away from us because they're speeding through space. They're receding because the fabric of space between us and them is stretching, little by little, like taffy drawn thin across eternity. If a galaxy is far enough away, the expansion can make it recede faster than light, not because it breaks the laws of physics, but because it drifts with a current that never stops widening. Those faraway places will never be seen again. Their light will never reach us, not even in infinite time. The universe doesn't hurry. It simply expands calmly, steadily, as if breathing in and never quite breathing out. And as this great expansion unfolds, our own solar system moves within it, like a small ripple on a much larger tide. It's easy to imagine the planets circling the sun in neat, flat rings, as if suspended in stillness. But the sun itself is in motion, orbiting the center of the Milky Way at nearly 1,000,000 kilometers per hour. As it travels, the planets follow behind, not just orbiting, but spiraling through space, tracing a graceful helix that winds across the galaxy. Earth's path through space is not a closed circle, but a flowing spiral, twisting endlessly ahead, never returning to the exact same spot twice. Everything is in motion: the sun, the planets, the galaxy itself, each one dancing to gravity's slow rhythm. If you could step outside time and watch from far above, you'd see our solar system moving like a luminous corkscrew, trailing threads of light through an ocean of stars. Around us, the Milky Way drifts through the cosmic web, tugged by unseen gravity, drawn toward distant clusters and away from vast empty voids. There is no such thing as stillness in space. Even as you sleep, you're gliding through darkness at unimaginable speed, turning with the Earth, orbiting with the Sun, spiraling with the galaxy, all wrapped in a motion so immense you can't feel it. What feels like rest is really part of a grand, unending drift, a cosmic rhythm in which every atom, every world, every dream is carried gently forward, far from stars, planets, and galaxies out in the deep intergalactic dark. You might think you would find true nothingness, but even the emptiest space has a temperature. It is not perfectly cold. It still carries the faint warmth of creation itself, a remnant glow that lingers everywhere. That temperature is about 2.7 Kelvin, just a few degrees above absolute zero. It comes from the cosmic microwave background, the oldest light in existence, the soft radiation released when the young universe cooled enough for atoms to form. Back then, everything glowed with a warm, orange brilliance. As space expanded over billions of years, that light stretched, its color sliding from visible to microwave, its heat fading into the near absolute chill we measure today. This dim afterglow now fills every corner of the cosmos. No matter where you are between galaxies, between atoms, it's there, wrapping you in the same ancient warmth that once lit the newborn universe. It's strange to think that even emptiness remembers. The glow we detect is not light from any star, but the quiet residue of the first time light could travel freely, the moment the universe became transparent. That radiation has been cooling for almost 14 billion years, softening with every heartbeat of cosmic expansion. In the far future, it will fade even more, stretching until its wavelength grows longer than a planet, its energy weaker than a whisper, but it will never vanish entirely. The universe can approach absolute zero, but it can never reach it, because the memory of heat remains. Even the most silent void hums with faint energy, with particles flickering in and out of existence, with the last photons of creation gliding endlessly through the dark. If you could drift there between galaxies, beyond light, you wouldn't hear anything, but you'd be surrounded by the echo of everything that ever was. The cosmos itself is never truly cold. It's just resting, breathing softly, carrying within its chill the final warmth of its first dawn. At the smallest scales of existence, reality trembles. Even when you zoom down past atoms, past their nuclei, to distances so small they can hardly be named, the universe refuses to sit still. Tiny fluctuations of energy flicker in and out of being, brief sparks that appear from nowhere, change the balance for an instant, and then disappear again. These quantum ripples are part of the fabric of existence, moments of randomness that never stop happening. According to many cosmologists, it was those very fluctuations that shaped the entire universe. In the first fractions of a second after the Big Bang, space itself expanded with unimaginable speed, a process called cosmic inflation. During that burst, the tiniest quantum irregularities were stretched out to cosmic scales. What began as invisible, random blips in energy became the seeds of structure, the faint unevenness that let matter clump together instead of spreading perfectly smooth. Over billions of years, those tiny differences grew into galaxies, clusters, and everything that fills the night sky. The stars above you, the planets beneath your feet, the molecules that form your breath, all trace their origin to the trembling of quantum fields at the dawn of time. It's humbling to realize that everything familiar was born from chaos so small it had no meaning, that the vast structure of the cosmos may be the echo of statistical noise. What we call the order of the universe might simply be the memory of its first uncertainty. Even now, every point in space is alive with that same restless hum. At the quantum level, nothing is still. Energy is always flickering, always shifting, as if creation itself never fully stopped. The galaxies and stars are just the larger ripples of that primordial vibration, frozen in slow motion. So when you look up at the night sky, what you see is the universe made visible by randomness, an ancient fluctuation, stretched into form. All the symmetry, all the beauty, all the light began as the smallest possible unevenness in nothing at all. Everything you know, everything you are, comes from that delicate tremor, the universe's first breath, whispered into the silence before there was sound. Not every star ends with a blinding flash. Some fade gently, pulsing with slow, rhythmic light, breathing their last across millennia. These dying stars, called variable stars, expand and contract as their outer layers warm and cool, creating cycles of brightness that repeat like a heartbeat too vast for any clock to measure. Some pulse every few days, others take months or even years, their light swelling and softening like the rise and fall of a tide. Each pulse is the echo of change deep inside, gas heating, pressure shifting, energy finding its rhythm before it slips away. From far across the galaxy, their glow seems to flicker softly, but in that flicker lies precision. Astronomers can use these regular pulses to measure the distances between worlds, because the rhythm of a variable star is tied to its true brightness. The slower the beat, the brighter the star. In this way, these stellar heartbeats have become cosmic markers, helping us map the shape of the universe itself. Even as they fade, they guide us, steady and faithful, like beacons blinking across the dark ocean of space. It's a tender thought that something dying can still give direction, that in its slow decline, a star continues to illuminate paths for others to follow. Their light carries both endings and beginnings, a reminder that decay and creation are always interwoven. Long after a star's final breath, its rhythm remains, stretching across space, a pulse that says, quietly and endlessly, "I was here." If you could look beyond visible light past the soft blues and whites of the stars into ultraviolet and X-ray wavelengths, you would see that our solar system drifts inside something vast and glowing. It's called the local bubble, a great sphere of hot, thin gas stretching hundreds of light years in every direction. For the most part, it's invisible to human eyes, but it's there, a faint halo carved long ago by ancient stars that lived and died before the sun was even born. Those stars ended their lives in supernova explosions, each one hurling shockwaves into the surrounding interstellar gas. Over millions of years, those overlapping blasts swept the space around them clean, pushing gas and dust outward to form a shell, and leaving the interior mostly empty, except for wisps of plasma, still warm from that ancient fire. Our solar system now floats quietly within this bubble, gliding through its near weightless air, surrounded by the thin remnants of cosmic violence long past. It isn't dangerous. You can't feel it or see it. It doesn't tug at your body or glow in the night. But it's there, an invisible room, in which the sun and its planets drift, like dust motes in a vast, sunlit chamber. This bubble connects with others, part of a patchwork of cavities scattered throughout our galaxy, each one a memory of explosions that shaped the Milky Way's air long before life ever stirred on Earth. So while you lie here tonight, breathing slowly beneath your own blanket of air, remember that air, your sky, your planet, all of it, moves inside a larger cocoon, You are wrapped in a bubble of starlight that once burned fierce and bright, now softened into a quiet warmth that holds us still. In the silence between stars, even the traces of ancient fire have become gentle. In one distant corner of the sky, there's a strange and silent tug, a place astronomers call the Great Attractor. It isn't a single object, but a vast gravitational region so massive that entire clusters of galaxies, including our own Milky Way, are slowly drifting toward it. Its pull is subtle yet irresistible, bending the paths of galaxies across hundreds of millions of light years, drawing them ever closer through the dark. We don't fully see it, because the dense plane of our galaxy hides much of that region from view, yet its influence is unmistakable, written in the quiet motions of everything around us. And beyond it, oddly enough, lies not more matter but less. Behind the Great Attractor is an enormous emptiness known as the dipole repeller, a region of space so underdense it seems to push galaxies away. This cosmic void stretches across hundreds of millions of light years, a place where almost nothing exists, not stars, not clusters, not even much gas. It's a strange kind of balance. On one side, the Great Attractor, pulling galaxies inward. On the other, a deep void, pushing them outward. Together, they form a cosmic tension, a gravitational duet that shapes the way our local universe moves. Every motion of our galaxy, every drift, every turn is a whisper between presence and absence, between mass and emptiness. Even the vast architecture of the cosmos seems to breathe in this rhythm, pulled forward by what is, pushed gently by what is not. It's comforting, somehow, to realize that both fullness and void have their place, that the universe is sculpted not just by what exists, but also by what's missing. We are carried between the two, balanced in motion, floating through a quiet tug-of-war older than time itself. And as we drift, we are reminded that gravity's touch can be soft, that even across billions of light years, the pull and push of the cosmos can feel less like a struggle and more like a dance. Right now, as you sit still and breathe, trillions of tiny particles are passing through you, ghost-like travelers from the heart of the stars. They're called neutrinos, and they never stop. Born in the fiery cores of suns, in the violent deaths of stars, and even in the first seconds after the Big Bang, these particles move through the universe almost untouched. They have mass, but barely. They carry energy, but rarely leave a trace. Every second, countless neutrinos stream through your body, through the walls, through the Earth itself, as if the planet were made of mist. They're so subtle that most of them could pass through an entire light year of solid lead without hitting a single atom. Only on rare occasions deep underground, in giant detectors filled with ultra-pure water or liquid argon, do a few of them collide, leaving the faintest flash of light that lets scientists know they exist. Each of those flashes is a message from the invisible, a record of a journey begun billions of years ago, when some distant sun burned or exploded and sent a piece of itself racing outward. It's humbling to think that these silent messengers are around you, within you, all the time. You are bathed in the same invisible rain that falls through every galaxy. It doesn't disturb you, doesn't alter a single breath, and yet it connects you to everything, to stars still burning and stars long gone, to the earliest fires of the cosmos still echoing in motion. In a universe full of brilliance and sound, neutrinos are the quiet ones, the unshakable witnesses that slip through everything, carrying the story of creation itself. They remind us that not all truth is seen or heard. Some simply passes through, endlessly, like light without glow, like time without measure. When a massive star reaches the end of its life, we often imagine it going out in a brilliant explosion, a supernova, blazing brighter than entire galaxies. But not all endings are loud. Some are quiet. The heaviest stars, those far larger than our sun, sometimes die without a single flash. Their cores collapse inward, and gravity wins so completely, so swiftly, that even the outer layers of the star are pulled straight down instead of being cast away. There is no detonation, no farewell light across the sky, just a sudden disappearance. Astronomers call this a direct collapse, and they've even witnessed its eerie traces. Stars that seemed steady for years, shining without change, then suddenly vanished, leaving behind nothing visible. No fading glow, no cloud of debris, only emptiness where a sun once was. In those moments, a black hole is born, silent and perfect, swallowing its own light in a single breath. It's one of the strangest paradoxes in the universe, an ending so absolute it leaves not a sound, not a mark, and yet creates one of the most powerful objects known. There's a certain peace in it, too. Not every story ends in fire. Some simply fold inward, returning to stillness. These quiet deaths remind us that even collapse can be graceful, that the universe allows for finales written in silence, for disappearances that are not destruction but transformation. Somewhere out there, a star may already be fading into invisibility, its last light streaming toward us now. A goodbye we'll receive long after the star itself has ceased to be. And when that final photon arrives soft, ancient, alone, it will tell us of a passing not marked by noise, but by surrender, a brilliant life drawn inward, becoming the calm gravity of eternity. Galaxies are not solitary wanderers. They move in clusters, in families, in delicate gravitational ballets that unfold over billions of years. Some orbit one another the way moons circle planets, their paths long and slow, their motion almost imperceptible across the span of human time. Our own Milky Way is not alone. It's surrounded by dozens of small companion galaxies, faint and scattered like tiny lanterns in the dark. The two largest, the Large and Small Magellanic Clouds, drift nearby, bound by gravity's invisible tether, looping around us in vast elliptical paths. As they move, their edges stretch and tear, leaving trails of stars that curl through the void like ribbons. Sometimes, these companions are drawn in closer, their stars peeled away by the Milky Way's stronger pull. In time, a smaller galaxy can be absorbed completely, its light blending into ours, until no boundary remains. These mergers are not violent in the way explosions are violent. They happen too slowly for that. Instead, they are like long embraces. Two systems of stars folding together, their histories mixing, their orbits rebalancing in quiet choreography. From afar, these cosmic dances would look almost serene spirals intertwining, streams of light connecting one galaxy to another, motion stretched across unimaginable scales. Each orbit takes hundreds of millions of years, each encounter shaping the next generation of stars. Even destruction here is gentle, more like a ripple than a crash. It's as though the universe itself prefers grace over haste. And so, in the vast silence of space, galaxies keep each other company. They meet, they drift apart, they merge and reform slow, patient movements in a dance that never truly ends. Perhaps that's the rhythm of everything. Even on the grandest scale, all things move toward one another, drawn by unseen forces only to blend transform, and continue on together through the dark. Among the most powerful events in the universe are those born from the quietest beginnings: a star's collapse, a flicker of magnetism, a moment when gravity and energy become one. Deep in the cosmos, there exist strange, compact remnants of stars called magnetars, neutron stars, wrapped in magnetic fields trillions of times stronger than Earth's. Most of the time, they are silent, invisible but steady, spinning alone in the dark. Yet under the right conditions, that silence can break into an instant of unimaginable brilliance. When a massive star collapses into a magnetar and releases its stored energy all at once, it can produce a magnetar hypernova, a flash so powerful it outshines entire galaxies for a few moments. These bursts, known as gamma-ray bursts, are among the brightest lights the universe can create. In a single heartbeat, they can pour out more energy than our sun will emit in its entire lifetime. The light races across billions of light years, arriving to us as a faint, fleeting shimmer, an echo of a cosmic storm already long over. What remains afterward is quiet again. A new neutron star, perhaps, or a black hole where light can no longer escape. Around it, the space is scarred by invisible fields of magnetism, like threads of fire frozen in motion. The universe holds these contrasts effortlessly: stillness and fury, silence and explosion. From far away, the magnetar's blaze is only a whisper of radiation. Up close, it would be creation and destruction in a single breath. It's humbling to imagine such power existing in something no larger than a city, a compact star pulsing with the energy of a billion suns, a celestial heart that beats only once. And when that pulse fades, the dark returns, calm as before, as if nothing had happened. In that stillness lies the lesson the universe seems to repeat. Even the brightest moments come and go, but the quiet always remains. When we look out into space, there's a limit to how far our eyes or even our most powerful telescopes can see. That boundary is called the edge of the observable universe, and it sits about 46 billion light-years away in every direction. But it isn't a wall. It isn't a place where space ends or folds back on itself. It's simply the furthest distance light has been able to travel to reach us since the beginning of time. Beyond it, the universe almost certainly continues quiet, unseen, and still expanding into regions we can never touch. Light has a finite speed, and the cosmos has been stretching for nearly 14 billion years. That means we're looking not at what is, but at what was. Every faint galaxy we detect is a glimpse into an earlier chapter of existence, its light set free long before Earth even formed. But space itself keeps growing, and because of that expansion, some galaxies are receding faster than light can cross the space between us. Their glow will never reach us, not even if we waited forever. The observable universe, then, is not the whole. It's our small bubble of visibility, a sphere of ancient light surrounding us, filled with all the photons that have managed to find their way here since the dawn of time. Outside it, the story goes on. Galaxies continue to form and fade. Stars are born and die. Matter moves and drifts, all beyond our reach. It's a gentle reminder that what we see is never the full picture. We live inside a kind of cosmic horizon, a shell of perception shaped by time and light. Beyond it lies an expanse we cannot measure, perhaps infinite, perhaps curved back upon itself like a dream with no edges. And though we'll never see it, it continues without us, quietly unfolding, softly expanding, more stars, more galaxies, maybe forever. At the heart of many galaxies lies a mystery of motion and fire, a supermassive black hole, millions or even billions of times heavier than the Sunday. Around these cosmic anchors, matter swirls in glowing disks, spiraling inward at nearly the speed of light. But not all of that matter disappears. Some of it escapes, caught in magnetic fields so intense they twist the falling plasma into narrow jets and fling it outward into space. These jets can stretch for millions of light years, thin and bright and impossibly long, piercing the dark like spears of light from a single point of gravity. From afar, we see them glowing in radio waves, forming vast lobes of energy that dwarf entire galaxies. They move almost silently, near the speed of light, powered by the rotation of the black hole itself, a dance between magnetism, matter, and motion. For a moment in cosmic time, they mark their presence with brilliance beyond comprehension, and then they fade, leaving behind quiet trails of plasma that drift through the intergalactic night. It's one of the universe's strangest ironies. The most powerful outflows we know come from the very places where light can barely escape. From the edge of silence, radiance bursts forth. From the depths of darkness, a signal brighter than galaxies themselves. These jets are the universe writing its signature across the void, proof that even where gravity reigns, energy finds a way to speak. And when the glow finally dims, when the plasma cools and the trails dissolve into the background hum, the black hole remains, patient and unseen. The echo of its act endures in space for eons, a reminder that even silence can leave a mark, and that the universe, in its quietest places, is always capable of astonishing light. Most stars in our galaxy move in harmony, orbiting the Milky Way in the same general direction, their motion guided by the slow rotation of the galactic disk. But not all of them follow that rhythm. There are wanderers, stars that drift against the current, defying the flow of billions. One of them is known as H437 5439, a star that races backward through the galaxy, cutting against the spiral's spin like a single spark moving upstream through a river of light. Its path is a mystery. Some believe it was once part of a smaller galaxy that merged with the Milky Way long ago, carrying with it the momentum of another world, another orbit, another history. Others suspect it was flung into its strange course by a gravitational slingshot, a near encounter with a black hole, or a dense cluster of stars that hurled it outward at incredible speed. However it happened, the result is a quiet rebellion, a star moving in reverse, out of sync with everything around it. It's easy to think of the universe as clockwork, precise, predictable, every object obeying the same invisible rhythm. But stars like this remind us that even in the grandest order, there are outliers, drifters, free spirits that carry a different motion. They travel their own path, untouched by the currents of the many, lit by their own momentum. Somewhere, far beyond our sun, H437 5439 keeps moving alone but unafraid, gliding backward through the Milky Way's endless river of light. It will never return to where it began, and yet its journey is perfectly its own. Even in the vast machinery of the cosmos, there is room for defiance, for chance, for a single wandering star that reminds us that not all who drift are lost. Deep in the heart of the Milky Way, near its restless center where stars crowd and dust swirls, there's a great molecular cloud, dense, dark, and alive with complex chemistry. When astronomers studied its composition, they found something unexpectedly familiar. Hidden among its tangled molecules was ethyl formate, a compound that, here on Earth gives raspberries their flavor and rum its warm, sweet scent. Of course, space doesn't really smell. The vacuum carries no air to carry aroma. Yet knowing that those same molecules drift between the stars is oddly comforting. In the cold darkness, far from any world, the seeds of scent, flavor, and life itself float quietly, waiting. Alongside them are other organic compounds, alcohols, sugars, amino acid precursors, all woven from carbon, hydrogen, and oxygen, born in the dust of dying stars and stirred together in the quiet of interstellar clouds. It's a reminder that chemistry, the language of life, is not confined to Earth. It hums everywhere, in the heart of nebulae, in the clouds that will someday become new suns, new planets, perhaps even new beginnings. When you imagine that dust near the galactic center, glowing faintly in infrared, remember that it contains the same building blocks as your own body, your breath, your heartbeat. While space may not truly smell like fruit or rum, the resemblance is poetic. It tells us that the universe is full of echoes, small familiar notes hidden in the vast unknown. Between the stars, drifting in silence, are the raw ingredients of taste, warmth, and memory. In a way, the galaxy does have a scent, not one of sweetness or spice, but of possibility itself. Far beyond the edge of our Milky Way, another great spiral galaxy drifts slowly toward us, the Andromeda Galaxy, our nearest large neighbor in the cosmos. It shines faintly in our night sky, a soft smudge of light that you can see with the naked eye, though few realize what they're looking at. A vast island of 1 trillion stars moving silently closer. Right now, Andromeda lies about 2.5 million light-years away. To human senses, it feels eternal, unmoving, but across the slow rhythm of cosmic time, it's already reaching out. In about 4 billion years, the Milky Way and Andromeda will begin to merge, pulled together by their shared gravity. It won't be a collision in the way we imagine, no fiery crash or sudden burst. Space is mostly empty, and the stars within each galaxy are so far apart that almost none will actually touch. Instead, the two systems will pass through each other again and again, stretching and reshaping their spiral arms like dancers entwining mid-step. Eventually, their halos of gas and dark matter, already overlapping today, will pull them into a single, larger form, a vast elliptical galaxy, often called Milkomeda. It will be a slow, graceful blending, two immense whirlpools of light folding into one another, their stars mixing, their histories combining. New stars may form from the gas stirred up in the merger. Others will drift farther out, finding new orbits in the remade sky. For any distant observer, it will look like a silent cosmic embrace, a meeting written in gravity, unfolding over billions of years. And in the far future, when that merger is complete, the night sky will be transformed. The glow of Andromeda will no longer hang faintly on the horizon. It will be woven into the same horizon, its stars, now ours. Even now, their halos are touching, their edges blending softly in the dark. The meeting has already begun, quietly, invisibly, in the deep fabric of space where time moves like a sigh. All around you, even in this very moment, there is light, ancient, invisible, and everywhere. It's called the cosmic microwave background, the faint afterglow of the Big Bang. You can't see it or feel it, but it fills every inch of space, even the air between your hands. It's the oldest light we can detect, released when the universe was only about 380,000 years old, long before the first stars, before galaxies, before time had found its rhythm. Back then, the cosmos was a dense, hot sea of particles and light tangled together. As it cooled, atoms began to form, and the fog lifted. In that instant, light was finally free to travel. The photons from that moment have been moving ever since, stretched by the expanding universe into soft microwaves, cool and dim but persistent. They arrive from every direction with nearly perfect evenness, a whisper of the first dawn carried across nearly 14 billion years. Today, we can detect that whisper with sensitive instruments, radio dishes, and space telescopes tuned to the faint hum of the early cosmos. What they reveal isn't just radiation, it's memory. Each photon is a survivor from the universe's childhood, carrying information about its shape, its temperature, its first breath. The glow is uniform, but not flawless. Tiny ripples in its texture show where matter began to clump, where galaxies would someday form, where stars would one day shine. If you could somehow see it with your own eyes, the night wouldn't be dark at all. It would shimmer faintly with the residue of creation, a veil of light older than every star you've ever known. That glow is still around you, still brushing past your skin, still echoing through every corner of the universe. The cosmos remembers its own birth, and in the quiet hum of that memory, everything that ever was continues to shine. Not every dying star goes out in brilliance. Some fade in secret, collapsing inward so completely that their light never reaches us at all. These are the failed supernovae, stars that reach the end of their fuel and begin to die, but instead of exploding outward, they fold silently into themselves. Deep inside, the core implodes, forming a black hole that swallows its own birth cry. The outer layers fall inward after it, vanishing without a single flash. Astronomers have actually seen this happen not through what appears, but through what disappears. A star, steady and bright one year, is simply gone the next. No glowing cloud, no fading embers, just a point of light erased. It's the quietest kind of death, and in that quiet, there's a strange grace. The energy doesn't vanish, it's just hidden, locked away beyond reach, a star's last warmth turned inward into darkness. The universe holds both kinds of endings, the spectacular and the still. Some stars go out like fireworks, scattering their ashes across galaxies. Others simply stop shining, slipping beneath the surface of time. Both are necessary. Both feed what comes next. Even in silence, creation continues, reshaping itself. When you think of the night sky, it's easy to see only the light, the stars that endure, the galaxies that blaze. But somewhere out there, just as many stories are ending unseen. The dark patches between the stars aren't empty. They're full of quiet departures. And perhaps that's what makes the cosmos so deeply peaceful. It doesn't mourn, it doesn't resist. It simply allows each thing to become what it must: light, shadow, or silence. Deep within the universe's web of gravity lie galaxies so faint they are almost invisible ghosts adrift in the dark. These are dark galaxies, places where gas and unseen matter outweigh the stars themselves. From afar, they give off almost no light. To most telescopes, they look like empty patches of sky. But hidden within them are clouds of hydrogen, whispers of dark matter, and the faintest glimmer of starlight, just enough for astronomers to know they're there. They are quiet systems, stripped of brilliance but full of gravity's weight. Some may have been ordinary galaxies once, their stars torn away in slow collisions, scattered into the halos of larger neighbors. Others may have failed to ignite at all, too diffuse, too fragile to ever light their gases into suns. Whatever their origin, they drift like unlit lanterns between the brighter cities of the cosmos, shaping the pull of their regions without ever revealing their own faces. It's a haunting thought that entire galaxies can exist unseen, that vast structures of mass and motion can pass through the ages almost anonymous. Yet even in their dimness, they play a role. Their gravity binds clusters together, steadies orbits, sculpts the quiet architecture of the night. They are part of the same harmony as the glowing spirals and blazing cores, just a softer note, a background hum of presence without spectacle. Not everything in the universe was made to shine. Some things are meant only to hold, to anchor, to shape what glows around them. These hidden galaxies remind us that existence doesn't always need to be bright to matter. Some parts of the cosmos simply are still, vast, unseen, and in their stillness, they keep everything else in place. In the deep dark of space, even the most silent things can move toward one another. Black holes, invisible and immense, sometimes form pairs, two shadows, circling each other in a slow, gravitational dance. At first, the motion is quiet, their orbits wide and steady, but as they spin, they stir the fabric of space-time itself, sending out tiny ripples, gravitational waves that carry away their energy, little by little. With every pulse, they drift closer. Over millions of years, their spiral tightens, their pace quickens, until at last, the two merge in an instant of pure release. The result is one larger black hole, perfectly smooth, perfectly silent again, but for a moment, the universe trembles. The collision sends a wave rippling outward through space and time, distorting everything in its path by less than the width of a proton. And yet, across billions of light years, we can feel it. In 2015, Earth itself shivered ever so slightly as one of those waves passed through a whisper from two colliding black holes a billion light years away. Instruments delicate enough to sense that tremor confirmed what Einstein had imagined a century earlier, that gravity, too, can sing, not with sound, but with motion, not in the air, but in the fabric of space itself. Since then, we've heard dozens more of these cosmic murmurs, each one a story of ancient mass meeting its twin, of energy folding itself into motion and then fading into calm. You can't hear them with your ears, but they are there. Waves crossing the universe. The slow rhythm of creation and collapse. The universe's own heartbeat stretched across the stars. For a brief moment, space-time itself hums, and then quiet again. The song ends, but the echo lingers forever. Not every star dies in a blaze. Some end their lives slowly, gracefully, taking billions of years to fade into quiet. Stars like our sun belong to this gentler kind. When they have burned through the last of their hydrogen, they begin to expand, growing vast and luminous, transforming into red giants. For a time, they glow with a deep, steady light, their outer layers swelling outward into the dark. Then, piece by piece, they shed those layers, letting them drift away into space like breath. What remains is small, but impossibly dense, a white dwarf, the still glowing core of the star that once was. It no longer burns or fuses, it simply shines with the leftover warmth of its long life. That ember will cool slowly, so slowly that no white dwarf has yet gone fully dark. The universe itself is not old enough for that to have happened. Every white dwarf that has ever formed still glows somewhere, faint but persistent, a soft bead of light scattered among the stars. One day, after trillions of years, they will fade completely, becoming black dwarfs, cold and invisible, the final quiet stage of a star's life. But that day is far beyond our reach, so far that even the word forever feels too short. Until then, these remnants will keep glowing, patient and constant, reminders of how even endings can be gentle. When you look up at the night sky, some of that light may already be from a white dwarf, tiny, ancient, and resolute. They are not fireworks, but embers. They don't announce their passing, but linger softly, giving the universe its afterglow. Their deaths are less like a fall and more like a slow, peaceful exhale of final warmth that fades not with violence, but with grace. Time itself bends under the weight of gravity. Near a black hole, where space is curved almost beyond comprehension, it doesn't flow the way it does here on Earth. To someone far away, a clock near a black hole would appear to slow, its seconds stretching longer and longer as it nears the edge of darkness. The closer it gets, the slower it ticks, until, from the outside, it seems to almost stop. This isn't an illusion or a trick of light. It's the way reality behaves when gravity becomes extreme. According to Einstein's theory of general relativity, space and time are not separate things. They form a single fabric spacetime, and gravity is simply that fabric bending around mass. The greater the mass, the deeper the bend, and inside those bends, time itself changes its rhythm. Around Earth, we can measure this on a tiny scale. GPS satellites, orbiting high above us, experience slightly weaker gravity, so their clocks tick a little faster than those on the ground. Without correcting for this, our maps would drift by kilometers each day, but near a black hole, the effect becomes profound. Time slows so much that minutes for one observer could mean years, centuries, or even millennia for another. If you could somehow hover safely just outside the event horizon, you would see the universe race ahead while your own moments stretched thin, each heartbeat lasting an eternity. To those watching from afar, you would appear frozen on the edge, light bending and reddening as it struggled to escape the pull. In that strange place, the rules we know blur into something deeper, where space folds, time stretches, and the universe itself whispers its most secret geometry. Black holes don't just trap light, they stretch time itself, twisting it into slow motion until it nearly stops, a silent reminder that even time, the most familiar flow we know, is fragile in the hands of gravity. Between the galaxies, there are places so empty that almost nothing stirs. No stars, no dust, no light, just a faint hum of leftover radiation and a handful of drifting atoms. These are the intergalactic voids, the coldest known places in existence. Their temperature hovers just above absolute zero, about 2.7 Kelvin, colder than any laboratory or mountain peak on Earth could ever reach. In those vast spaces, there's nothing to hold warmth, nothing to glow or move, except the occasional stray particle crossing unimaginable distances. It is hard to imagine such stillness, millions of light years of almost pure emptiness, and yet, even there, the universe is not completely silent. A faint background warmth remains, the residue of the cosmic microwave background, the afterglow of the Big Bang. That whisper of heat is the last echo of creation, stretched and cooled by billions of years of cosmic expansion. It seeps through every corner of the cosmos, even the darkest ones, reminding us that the emptiness we see is not absence, but history. Every cold photon, every trembling wave of energy carries the memory of when everything was fire and motion. If you could stand inside one of those voids, though there would be nothing to stand on, nothing to breathe, nothing to see, you would be surrounded by a silence deeper than thought itself. The nearest galaxy would be so far away it would appear as a faint, thin smudge. You would feel no direction, no warmth, no motion, only stillness and the quiet drift of time. These empty regions are the universe's deepest shadows, cold but not dead. They cradle the leftover glow of beginnings, holding the faintest whisper of creation, the breath of a cosmos that once burned and now only remembers. In its earliest days, the universe wasn't transparent at all. It was filled with a dense, hot plasma, a fog of charged particles so thick that light couldn't travel freely. Photons bounced from one particle to another like echoes trapped in a storm. For hundreds of thousands of years after the Big Bang, this glowing soup of matter and energy kept the cosmos shrouded in brilliance, but also in opacity. Then, as the universe expanded, it began to cool. Around 380,000 years after its birth, the temperature finally dropped low enough for electrons to combine with atomic nuclei, forming the first neutral atoms. In that instant, the fog cleared. Light, freed at last, began its long journey through space. That light still surrounds us today as the cosmic microwave background, a faint, ghostly glow from the moment the universe became see-through. Since then, the universe has continued to grow more transparent. As stars formed and galaxies took shape, they flooded space with light. The once opaque plasma gave way to clarity. Vast regions that were once dense and glowing are now thin and open, allowing photons to cross billions of light years without obstruction. Every step of cosmic history has made the universe clearer, calmer, and easier for light to move through. In a sense, creation has been a slow unveiling, a gradual lifting of a universal veil. Space, that once blazed with blinding heat, is now cool and quiet, letting light glide almost untouched across its vastness. Today, that same light passes through you, through oceans, through mountains and air photons that have traveled since the dawn of time, no longer trapped, no longer scattered. The universe, once glowing and opaque, now lets light pass through almost unimpeded, a transparent cathedral of silence and motion. In the spring of 2019, humanity looked into the dark heart of the universe and finally saw a shadow that had only existed in theory. The Event Horizon Telescope, a network of observatories spanning the Earth, captured the first direct image of a black hole, or rather, the space around it. What we saw wasn't the black hole itself, because nothing, not even light, can escape its pull. What we saw was its outline, a glowing ring of hot gas circling a perfect absence. That image came from the galaxy M87, more than 53 million light-years away. For years, astronomers synchronized telescopes across continents, timing them with atomic precision to act as one planet-sized eye. When the data was finally stitched together, it revealed something hauntingly simple: a dark center surrounded by a halo of fire, light twisted and bent by gravity into a glowing circle. It was more than a picture. It was proof of geometry and gravity in motion, of light being pulled almost but not quite into eternity. That faint orange ring is light's final stand before falling forever inward. It is the edge between what can be seen and what cannot, between space and whatever lies beyond time. To look at it is to see an ancient theory drawn in real light, the first visible evidence of a cosmic secret whispered by Einstein a century ago. For generations, Black holes had been imagined, simulated, described in equations, but never witnessed. And now, there it was, a shadow carved by gravity itself, caught not by myth or metaphor, but by patience, technology, and a quiet act of collective wonder. That faint circle, glowing in the darkness, became one of humanity's most peaceful triumphs, a reminder that even in the most unfathomable corners of reality, light can still reveal the shape of mystery. On clear, quiet nights, when the air is still and the lights of the city fade, you can look up and see an entire galaxy with nothing but your eyes. No telescope, no lens, just you and the dark. In the northern sky, stretching faintly between constellations, there's a soft, misty oval, the Andromeda Galaxy. It looks small and delicate, like a smudge of cloud, but that blur holds more than 1 trillion stars. Andromeda is our nearest large galactic neighbor, about 2.5 million light-years away. That means the light you see began its journey long before humans walked the Earth, long before Earth itself had taken its modern shape. Every photon hitting your eye tonight has crossed millions of years of expanding space, carrying the memory of suns that may no longer exist. You're not just looking outward, you're looking backward in time. That soft shimmer is ancient light, a message from another island of stars drifting toward us through the quiet ocean of the cosmos. In about 4 billion years, Andromeda and the Milky Way will meet and merge, their stars swirling together into one vast elliptical glow. But for now, they're two dancers in slow motion, gliding through darkness toward an embrace no one alive will ever see. There's something humbling in that, standing beneath a silent sky, feeling the faint light of another galaxy touch your eyes. It's a connection that needs no telescope or theory, just stillness, just wonder. A reminder that the universe is vast, but it's also close enough to reach you, a gentle glow from something ancient, still drifting in the dark. In 2015, a quiet ripple reached Earth from more than 1 billion light-years away. It wasn't light or sound, but a tremor in the very fabric of space itself, a whisper from 2 black holes colliding in the deep past. A small observatory named LIGO, built with impossible precision, caught that whisper. The signal was faint beyond imagining, stretching and squeezing space by less than the width of a single proton. Yet it was enough to confirm one of Einstein's most elusive predictions. Gravitational waves are real. These waves aren't made of matter or light. They are the rhythm of space and time responding to cosmic violence. When massive objects collide black holes, neutron stars, they send out ripples that travel across the universe, carrying with them the memory of what happened. LIGO's instruments, long tubes of mirrored laser light, are like ears pressed gently against the surface of reality, listening for tremors older than Earth itself. That first detection was described not as a flash or explosion, but as a chirp, a soft, rising tone that marked the moment 2 invisible giants became one. Since then, we've heard dozens more, each one a story of distant gravity, folded into the silence of space. Every wave that reaches us has crossed eons of emptiness, yet still moves us, literally, minutely, as it passes. It's a tender thought. Somewhere in the universe, 2 black holes met and vanished into each other, and billions of years later, the quiet ripple of their union brushed past Earth. Caught by a tiny detector on a small blue planet turning in the dark, even the universe's grandest collisions arrive to us as the gentlest whispers. The universe is stretching, and it's doing so faster than ever before. Every second, galaxies drift farther apart, carried by the quiet expansion of space itself. It's not that they're flying away through space. Space is growing between them, and in the most distant reaches, that expansion has become so swift that some galaxies are now receding faster than light can reach us. Even if we waited forever, their glow would never arrive. They've crossed what cosmologists call the cosmic event horizon, a boundary beyond which light, time, and connection can no longer bridge the distance. These galaxies aren't gone. They still exist, still shine, still orbit their own stars. But to us, they are already beyond touch, slipping gently into eternal night. Every year, a few more galaxies fade past that invisible edge, their light stretched thin until it disappears into the silence. Over trillions of years, this process will continue, and the visible universe will shrink around us, not because the cosmos is collapsing, but because it's letting go. It's a strange kind of stillness. The universe is not dying. It's simply moving beyond what we can see, carrying its own secrets beyond the reach of our eyes. In the grand, slow rhythm of cosmic expansion, everything drifts apart, not in chaos, but in peace. We live in a moment when the sky is still rich with light, when distant galaxies still send their messages across the dark. Someday, that sky will fade, and only the nearest stars will remain. But even then, the memory of what once shone will linger in the faint microwave glow, in the dust, in us. The cosmos isn't just growing, it's also quietly letting go. Not every black hole is born from a dying star. Some may be older than stars themselves, primordial black holes, forged in the first instance after the Big Bang. In that newborn universe, matter and energy surged and settled in uneven waves. Where the density briefly ran too high, just for a heartbeat of cosmic time, gravity could have pinched space so tightly that tiny horizons formed, trapping everything inside. No flames, no collapse of a sun, just the early universe knotting itself into darkness. If they exist, these ancient remnants could span an astonishing range of sizes, from smaller than mountains to more massive than stars. Some might have evaporated through a slow quantum leak over unimaginable ages. Others could still be wandering the cosmos, untouched and invisible, except for their gravity. We haven't seen one directly. We've looked for their signs in microlensing flickers, in the patterns of cosmic radiation, in the motions of stars, and still they hide. Yet the idea persists, steady as a pulse in the background of theory. Perhaps these early black holes seeded the formation of galaxies, giving matter a place to gather and grow. Perhaps a multitude of the tiniest ones helped sculpt the young cosmos and then faded into nothing, leaving only their influence behind. Some even wonder if a population of primordial black holes could account for part of the universe's dark matter, silent weights tugging on starlight from the shadows. It may be unlikely, it may be partial, it may be wrong, but the possibility is a quiet door the universe keeps open. There's a certain calm in imagining them, small, ancient mouths of gravity drifting through the dark, older than any star, older than any world fossils of the first seconds after time began. They do not blaze, they do not sing, they simply endure, carrying the hush of the beginning within them, as if the universe left a few knots in its earliest weave and never bothered to untie them. At the smallest scales, the universe keeps a secret handshake, quantum entanglement, a link so deep that two particles can share a single state, no matter how far apart they drift. Touch one here, and the other answers there, not by sending a message faster than light, but by revealing that both were always part of the same quiet whole. It doesn't violate the speed limit of the cosmos. It just sidesteps the idea that things must be separate to begin with. To our everyday sense, this feels impossible. To the quantum world, it's simply how being works. Some physicists suspect this invisible bonding might be more than a party trick of particles. It could be woven into the very fabric of space-time, tiny threads of connection that help hold geometry together, stitching near and far into a single, continuous cloth. In certain ideas, the smoothness of space emerges from countless entangled links, as if reality's softness were the sum of many microscopic ties. Pull enough of those ties apart, and space itself might fray. Imagine the early universe, hot and dense, making pairs of particles the way a fire cracks and pops. As expansion pulled everything apart, many of those pairs remained linked. No wires, no signals, just a shared state, stretched thin across widening space. If so, there may be quantum echoes running from one corner of the cosmos to another, correlations too subtle to see with eyes, but present all the same, like the faint resonance of a bell long after it's struck. Entanglement doesn't let us whisper across galaxies or rewrite causality. It offers something gentler, the reassurance that separateness is not the whole story. When you look up into the night, the distance, the emptiness, the hush, know that invisibly, underneath, the universe is braided together. What looks apart is, in some quiet way, already shared. Perhaps that's why the dark feels less lonely when we breathe slowly and listen. Beneath the stars, between the galaxies, within the cold there may be threads of relation finer than light, binding the far to the near, the then to the now. Not a signal to hear, not a map to draw, only a soft, persistent kinship written into the base of things. If you could sink down to the scale where reality flickers, you might feel it, the gentle tug of connection, everywhere and always, quantum echoes from the dawn, still present in the emptiness between worlds. And now, as the stories of the stars quiet down, let yourself drift with them. The universe, for all its vastness and mystery, has never been in a hurry. It expands softly, breath by breath, carrying galaxies like lanterns through an endless night. Every pulse of light, every whisper of gravity, every silent echo from the beginning, it all flows together into the same calm rhythm that hums inside you now. Close your eyes. Feel that rhythm steady and low, like the tide beneath thought. Beyond your walls, beyond your sky, entire worlds are turning in silence, stars cooling, light stretching, atoms vibrating gently in the dark. The same laws that cradle galaxies also cradle you. The same stillness between stars lives in the quiet between your breaths. You don't have to hold the universe in your mind. It's already holding you. Every atom in your body was once inside a star. Every heartbeat is a small continuation of that ancient burning. You are part of this, part of the long, slow unfolding, the luminous drift, the infinite calm. So let go. Let the day dissolve into shadow, and let your thoughts scatter like dust in sunlight. The cosmos will keep spinning. The light will keep traveling. And you, small, bright, and made of the same silence, can finally rest. The night is deep and patient and kind. Sleep now, traveler among stars. The universe is still singing. You only need to listen.